This is the second day of notes for chapter 12 and second day out of 2. We're going to finish up today. Yesterday we talked about gases. Today we're going to talk about liquids and solids. Kinetic theory was used to talk about gases. It can also explain how liquids and solids behave. The gases, the molecules are small tiny spheres that have lots of space around them. They hit and bounce in random straight line motions, and when they collide with perfectly elastic collisions. Well, when we cool things, they have less energy when they hit, and these attractive forces, sooner or later when they hit, those attractive forces are going to kick in and they're going to not let them escape, and that's when we have liquid that's able to move around one another like steel ball bearings that are magnetic. When they cool even further, they no longer move around, they vibrate in place, kind of like your car sitting in a parking place vibrates, and that would be the solid state. And that can all be related to kinetic theory. The liquids are considered incompressible. We already talked about the compressible, incompressible ideas, but gases are compressible. Liquids and solids are not compressible. Liquids take the shape of their container, much like this. When I have it like this, the liquid is the shape of the bottom. Now it's the shape of the other bottom, but it doesn't fill the container. The top has some gas in it, not that liquid. Gases both take the shape and fill the container, so they're a little different in how they define by that. Viscosity. Viscosity could best be described as the thickness of a liquid or the slowness of its movement. If we had a race between pancake syrup and water, the pancake syrup would lose because it is a viscous substance. The bigger the molecules, the more viscous, because the bigger molecules rub against each other more as they move. Water's viscous, but it's not viscous as pancake syrup or really any of the sugars. Sugars, tree sap, they all have very large molecules and they're very viscous. The larger the molecule, the more the viscosity. Also, viscosity decreases when you heat a liquid. So if we heated the pancake syrup, it would flow faster. Surface tension, cohesion, and adhesion. Cohesion, like co-worker, would be where two like molecules stick together. Adhesion would be where water or some molecule sticks to something else. So the meniscus is formed because water sticks to the glass on the side and it droops in the middle. Adhesion would be sticking to something else. Cohesion sticking to the same molecule. Water to water would be cohesion. Adhesion causes capillary action. And we've got an example here that's kind of hard to see on the video, but I actually have a capillary tube in here. And the capillary tube, the liquid is up about this high in the little narrow tube because it climbs up that tube since it's narrow. It's like you being in a narrow well where you can put your feet on one side and your back on the other. You can kind of climb your way out. The liquid is in a narrow tube, so it's kind of climbing up. This is one of the things that helps water go up the small capillary type tubes in the tracheids of the xylem in trees. Solids. Solids are generally more closely packed. There are some exceptions. Water is one of those exceptions. Water is less dense as a solid because as it forms its crystal, it kind of unfolds and takes more space. So it's more dense. Unit cell. If we were to take a crystal, let's say salt, which is a cubic crystal, we hit it with a hammer, break it into smaller cubes. Hit it with a hammer, break it into smaller cubes. Keep going smaller and smaller and smaller until we get to the smallest single shape that's still a cube. That would be the unit cell. When we built the labs in chapter 10 for the ionic compound labs, the model lab, that was a unit cell we were making. It was the smallest part that has the same shape as the big crystal. Some solids don't have crystals. They are amorphous. Glass, rubber, plastic, they're amorphous solids because they don't have crystalline structure. A crystalline network solid, so some covalent compounds have this network type crystal, but it's not the norm. When molecular compounds freeze, sometimes they have crystalline structure. This is a model of a diamond. Diamond would be a carbon compound that has a three-dimensional network structure. It's called a network solid. Very strong, very high melting point, which is odd for molecular compounds. Most of them are low in melting point. So we talk about phase changes. In this diagram, you should be able, if you have this chart on the test, you should be able to label freezing, melting, condensation, vaporization, solid, liquid, and gas in the correct spot. Notice that the arrows are important because going liquid to solid is freezing, whereas going solid to liquid is melting. So look over that and make sure that you could fill in those blanks correctly if you were given that. And this shows you water phase change. We go from ice to water to liquid. Notice that the middle one, the one that has the water, that's more dense because water is more dense than ice. The ice is more spread out so that it'd be lighter, it'd be less dense. Ice is less dense. That's important because the lakes up north, if the ice was more dense, ice would sink to the bottom, the next layer would sink, the next layer would sink, and the whole lake would be filled with ice. So the fact that ice is less dense, that's an important thing for nature. Okay, state changes. This page has all of the state changes: fusion, melting, boiling, vaporization, evaporation, solidification, freezing, condensation, sublimation, deposition. I would make some flashcards with these so that you knew these terms. There are going to be a few more terms in this chapter because there's a little bit less math involved. Note that boiling and vaporization aren't exactly the same. Vaporization is like the big circle on a Venn diagram. Boiling and evaporation are kind of subsets, where boiling is only the conversion from liquid to gas at the boiling point, and evaporation is only the conversion from liquid to gas in an open container below the boiling point. So look over those, make sure that you know those. When we add the word point to the phase change, it means the temperature. So like melting has a melting point, which is the temperature where it occurs. So we talk about vapor pressure. Vapor pressure is the pressure inside of a sealed container caused by the vaporization, and we measure that with a manometer. You can see here we have the manometer connected, and we actually discussed that on the previous lecture. So the manometer is the device that measures sealed container pressure, vapor pressure. And then the phase changes and exothermic, endothermic nature. Look through these because I will have a couple of questions on the quiz or the test, and I'll say which of the following is an exothermic reaction. Exothermic are freezing, condensation, deposition. Endothermic would be boiling, melting, and sublimation. Good flashcard stuff for those two. This big chart is pressure versus temperature, and we actually are graphing how the liquid, solid, and gas occurs based upon those different pressures and temperatures. Notice there's one point in the center where they all come together called the triple point. If we had a container that had all of these, this pressure and this temperature, I think it's 0.016 degrees and almost 0 atmospheres. At that pressure and temperature, all three states exist at one time. It's called triple point. There's a place in New Mexico called Four Corners. It's where four states come together. It kind of reminds me of that. You can stand in four states at the same time. At that point, you have solid, liquid, and gas in the same container at the same time. And of course, this last page just really kind of describes what we just talked about what a phase diagram is, pressure versus temperature. And then the triple point is that point where the pressure and temperature are right for all three states to exist at one time. That's kind of the end of the chapter in a nutshell, and we went through it pretty quickly, but you can always kind of stop and pause and rewind if you need to, and work through your review and the practice problems, study up, and good luck.